Vous la guinée, c'est pas bon. Si la guinée nous permet. Non, il y a un peu. Nanti itu apa istilahnya ini tuh agak gitu kan kita jelas. Oh, lapor. Oh, delivery. Oke, silakan. Silakan.
छिटाले सारा भिजाई दक्षिण लंका भारत तारा उदाई उत्तर चीन तिब्बत उदलेरी पाएंगे ज्ञान को बजलो मुहाना शिवलिंगी लाएंगे सृष्टि को बजलो दीवाना गौचरी पे निभाई ज्योति को पंख उचारे गौचरी पे निभाई ज्योति को पंख उचारे जय 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 निभाई सुंदर शांत विशाल सुंदर शांत विशाल पश्चिम किल्ला कांगड़ा पूर्व माटिस्टा पुगे दियो कुलशक्ति को सानोमा कहिले हामी चुके थियो हामीले जीवन उठायो एसियाको माझमा सभ्यता बास बसेथ्यो आइरहेकी साँझमा ज्योतिको पंख उचाले गौचरी पे निभाई ज्योतिको पंख उचाले गौचरी पे निभाई ज्योतिको पंख उचाले जय 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 नेपाल सुंदर शांत विशाल सुंदर शांत विशाल गौचरी पे निभाई ज्योतिको पंख उचाले ज्योतिको पंख उचाले जय 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 नेपाल सुंदर शांत विशाल हिमालय नरहे हिमालय नरहे कराई हाम्रो सुन्दर दुर्ग हिमालय हिराको माटो र पानी पहिरो खानु धरतीका छोराको ये कहाँबाट संसार हेर्छौ सम्झामै नरहे सम्झामै नरहे सम्झामै नरहे दसैँ र तिहार रमाइलो हाम्रो छुट्टा र ख्यालीले हृदय हाम्रो झुरमुराउँछ जितको जालीले बैशाखको तालमा नाचौँला कहाँ माधवै नरहे माधवै नरहे माधवै नरहे सानो भइल्यो हिमाल नेपाली हामी रहौँ पालै नरहे पनि बोल्छ मिठै ध्वनि सारङ्गी मिठै ध्वनि कसरी मधुर बनाऊ मिठोलाई पनि सारङ्गी तरिके पनि बोल्छ मिठै ध्वनि सारङ्गी तरिके पनि बोल्छ मिठै ध्वनि गाली गरौँ आफ्नै बोली अपवित्र हुन्छ त्यसै बसौँ असत्यको त्यसै जित गाली गरौँ अपवित्र हुन्छ त्यसै बसौँ असत्यको त्यसै जित हुन्छ मूर्छा परिवार सरस्वती पनि सारङ्गी तरिके पनि बोल्छ मिठै ध्वनि सारङ्गी तरिके पनि बोल्छ मिठै ध्वनि पहिलो गल्ती रमाइ दोस्रो गल्ती होइ यो पापमा नउचिने छैन मान्छे कोही पहिलो गल्ती रमाइ दोस्रो गल्ती होइ यो पापमा नउचिने छैन मान्छे कोही क्षमा गर्न सक्दिन आफैलाई पनि सारङ्गी तरिके पनि बोल्छ मिठै ध्वनि सारङ्गी तरिके पनि
Nelson Mathematics, and this is endorsed by Cambridge International A-Level. And writer of this book is J. Chambers, J. Crosser, and P. Ballon. So first of all, I assume that my students have done the theoretical idea about the representation of data, but I'm going to explain a little bit more before I start this exercise example problem. So if you look at this example, it states that a machine cuts lengths of wood. A sample of 20 rods gave the following results for the length x centimeter, and these are the information given. So summation of xf is 997 and summation of x square f is 49711. And then find the mean length of the 20 rods. And second part of this question is to find the variance of the length of the 20 rods. So we know that x bar, also called arithmetic mean, as already stated. So this is sum of observations divided by number of, and this summation x by n ratio is called x bar, and that we have already seen earlier. And so this sort of formula is for individual series of data. Also, if you talk about a standard deviation, and then it is denoted by sigma, is under root 1 by n summation x minus x bar. You can also express like this: 1 by n, summation of x minus x bar over n, and no, a square, and then this is a square. Now what happens when you open this bracket? Your sigma will be like this: summation of x squared by n minus x bar square. And also, if you like, you can write summation of x squared by n minus summation of x over n square in place of this x bar. And if for frequency, density, for frequency distribution, that means if any of the item has more than one frequency, in that case you can write the same formula by introducing f. So f stands for frequency. So in that case, your x bar will become summation of fx by n. So just we have to introduce f with x. So where f is the frequency of each item in the given series of data. Okay, and somewhere you might have seen that this is also written like this: 1 by n summation of fx. So these two are the same things. And your standard deviation sigma will become under root of summation of f x minus x bar square over n, or somewhere you can find it written like this: 1 by n summation of f x minus x bar square, where x bar is the arithmetic mean. So you can write it in either way. If you open the bracket with little simplification, then this formula is found to be like this: summation of f x square over n minus x bar square, or also you can write summation of, if it is fx square, you can write x square f also divided by n, minus, in place of x bar you have summation of fx divided by n. So you can write this way also: summation of xf over n, and then because of this square there will be whole square. All right, so these are the formula that we know about. And in order to find the variance, if you are going to find, so variance is simply the square of a standard deviation. So this is sigma squared. If I am taking this formula, in that case my variance formula is going to be summation of x squared f over n minus summation of x times f over n square. So simply, if you square the standard deviation, that is called the variance. Or standard deviation, if you want to define in terms of variance, so positive square root of variance is called the standard deviation. So now here in this example, this sum states that a machine cuts lengths of wood, a sample of 20 rods. So in question number 1, if I'm talking of find the mean length of the 20 rods, that means n is given as 20, and then x bar equals to what in this case? 20 rod gave the following results. So these are the results given, so summation of x given, and then this information is also given, and then you have to find the mean of the 20 rods. So 20 rod means there are n value as 20 and x bar is given as, no, x bar we have to find it. Okay, so we know x bar equals to 1 by n summation of fx, because this is not the individual series. If there is f, that means it is not from the individual series of data. Or you can also write summation of x times f, that is xf by n, and your fx value is given as 997, and then n value is 20. Take a calculator, then you can write 997 divided by 20 here, so it is going to be 49.85. So our mean value is 49.85. You can see it. All right, now in second question number, you have to find the variance of the lengths of the 20 rods. So let's calculate based on the given sort of information. You have to write the formula, so you can check it here that which formula would be better, like the formula in this form or in this form. So definitely it is given as x squared f. So we require the open value for this, open space for that. So this sort of formula is required. So we use this formula for variance. So here variance is going to be sigma square. You don't need to write sigma square at this moment, but you must know that it is denoted by sigma, standard deviation is, and hence variance is denoted by sigma square. And this formula you have already seen that this is x squared f by n minus, either you can write xf by n summation of fx by n square, or x bar x square. Both of the thing will work. Why? Because we have already calculated the value of x bar, so even if you write x bar, that works. At the same time, we are given the value of xf, so we can find this directly from the given information. So you can do in either way. So here now summation of x squared f is given as 49711 over n value is again 20 minus, so instead of writing all this sort of information, I will write this mean value 49.85 squared, because this is itself is x bar, so we can write this x bar value. Now you take your calculator again, and then this is 49711 divided 20 minus, start the bracket, inside the bracket there is 49.85, close the bracket, then a square, and our answer is 211 by 400, and if you write in decimal form, it's going to be 0.5275. All right, so this is the exact number, so you don't need to round off this to the any significant figure. So this is the answer. Or you may also try yourself the calculation. Okay, I'll now move forward to another question. Okay, this is about combined mean. Combined means if you are given more than one sets of data, in that case you can find mean, and if needed the standard deviation also for all the data in the combined form. So here we are taking the example of only two data. So one data is represented by x and another by y, and this is the formula to use the combined mean. So let me discuss a little bit. So say it is one as x values, another as y values, and if you calculate values means it is 20, 30, 11, something like this, and for y also, then you will have here x bar value. If you have some number, and then similarly you'll have y bar values also. So if you are writing the combined mean, for example, combined mean of the set of data for x and y, that means it has mean x bar, and then another has mean y bar. So we have two items now. So mean of these two items is x bar plus y bar divided by 2. So once you calculate the mean of these two data, suppose this has a single value, this is another single value. So we have two items actually. So when we have two items, we are taking the arithmetic mean of the two item, and arithmetic mean of x bar plus y bar is 2, and this is called the combined mean of these two sets of data. This is possible for more than two sets of data also, but here we will discuss only about the two sets of data. And you know that x bar is equals to summation of x by n. So if you cross multiply, then it is going to be summation of x equals to n x bar. Okay, so as you need, you can write either this or this, depends on how you need this. So for the size of data for x, I will call it as 1, so we can write n1, and size of data for y, I will call it as n2. So x bar equals to, we can write summation of x, summation of x by sorry, it should be yes. So we have n2 size, so it is given as n1 and this is given as n2. Okay, sorry for that. So summation of x, you can write n1 x bar, you can write for n1 x bar of x, and then for similarly you can write for y bar is going to be summation of y by n2, therefore n2 y bar is going to be summation of y, so that for n2 y bar you can write summation of y, and then this is divided by, let's check it first of all. No. Because we are taking the combined mean, so that we have to add up all these values together. So this, for that, this is summation of x, and then for this it is summation of y, and length of, this is simple thing, this is the length of this value is n1 and this is n2. So here the total number of observations for first is n1, and then for second is n2. So your combined mean formula is now, summation of x means total of x plus total of y divided by n1 plus n2. Now after this step, if you are going to express that in terms of x bar and y bar, then for summation x you can write n1 x bar, and for summation y you can write here summation n2 y bar, and divided by it is n1 plus n2. So you can remember the combined mean formula either in two ways, either by taking the total of xs and ys divided by total number of things, or by using this another formula. So in this way, if you combine the mean of two data, this is called the at least two data, then this is called the combined mean for the or the mean for the combined data. Next thing now, so we have one formula as this that we are going to use here, and another formula for the standard deviation is this. So similarly, if you combine the standard deviation of two data, and if you go through the derivation that I had explained for combined mean, then you'll have the value of sigma s like this. Actually, proof is not necessary at this time, so we'll use the formula directly here. Now, this example states that the following table shows the mean and standard deviation of heights of 20 boys and 30 girls. And these are the informations for the boys and girls, which is given that the mean for boys is 160 and variance is 4 centimeter, standard deviation is 4 centimeter. For mean for the girl is 155 centimeter, and standard deviation for the girls is 3.5 centimeters. So based on this information, you have to find the mean and standard deviation of the heights of the 50 children. So because here it says that how many men, following table shows the mean and standard deviation of 20 boys. So n1 is 20 over here, and then 30 girls. So n2 is going to be 30 here, and your total is going to be 50 people or 50 students, you can say. So in order to find this mean, so mean equals to, we know by this formula, it is summation of x plus summation of y by n1 plus n2, and for this you can write n1 x bar, say this is this is x bar for boys and y bar for girls, and then this is n2 y bar over n1 plus n2, and then n1 value is 20 times x bar is 160 plus n2 value is 30 and y bar is 155. Instead of writing x and y, you can also write x1 and y1. So n1 is now 20, and then this is 30, so altogether this is 50. Take a calculator, then calculate this value. So 20 times 160, and then 150 times 30, and then this. So we have now 20 times 160, then plus 30 times 155. Okay, and then divide this by 20 plus 30 as 50. So combined mean in this case is 157. And you can also find this way, like first of all, alternatively, you can first find summation of, you have x bar equals to summation of x by n1. So it is summation of x as n1 times x bar, and n1 value is 20 here, and x bar value is 160. So 16 to the 32, and how many zeros? 2 zeros, 1 and 2 zeros. And similarly, your y bar will be summation of y by n2. That will give you summation of y after cross multiplication. So it is going to be n2 y bar. N2 is given as 30 times it is 155. So don't do mental calculation here, where it can, there will be chance of making mistakes. So it is 30 times 155, and this value is 4650. 4650. And therefore your mean in this way is mean, you know the formula for that, summation x plus summation y divided by n1 plus n2, and that is going to be equal to, so summation x we have got is 3200 plus 465 zeros, and then n1 is 20 and n2 is 30, and then we have, can use calculator, 3200 plus 4650, and then divide this by 50, and it is going to be again 157. So when you change the formula, when you change the way, destination doesn't change. So there should be always the same answer, whatever way you go through. All right. So in this case, I stressed on to use the calculator. So while in your practice mode, you can use the mental calculation also in this sort of calculation. But in exam, I suggest you not to take the risk, because the exact answer also carries marks over there. So in place of 157, even though your method is correct and your answer is wrong because of the wrong calculation, then you will lose some mark in your exam. Therefore, I strongly suggest you to use calculator while making the calculation, especially in exams, because calculator is allowed there. And yeah, we have done with find the mean only. So we have done for mean only. Now we need to find the standard deviation also. So you know that the find the mean and standard deviation of this sort of thing. So first of all, so I'm doing the second part of this question to find standard deviation equals to what. So first of all, we write the formula for standard deviation. So this formula is summation of x squared plus summation of y squared, all inside the root, then n1 plus n2 minus mean squared. So here mean squared means it must be here combined mean, because we are using the formula for the combined set of data here. But in the information, you can see that you are given x bar for boys as 160, and hence your summation x is there. Summation x is 3200, 3200, and y bar is given as 155, and we have just seen that your summation y value is 4650. So it is 4650, and n1 value was 20 and n2 value was 30. But actually you require summation x squared value or summation y squared value. Both are not given here. So we have to get these values of summation of x squared and summation of y squared from the given set of data. So how you get it? We know standard deviation equals to summation of x squared by n minus x bar squared. Or you can write standard deviation. So sigma 1, you can say sigma 1 is given as 4 for this, and for this you can say sigma 2 value as 3.5. So we are working with first data first of all. So sigma 1 value is standard deviation is given as 4, and then under the root summation of x squared is not given, and then for the first data n1 value is, this is n1 value is given as 20, and then x bar squared means you take it this x bar squared, so it is 160 squared. Now when you square to the both sides, then it's going to be summation of x squared by 20 minus 160 squared, and so here 4 4 are 16. So what we have to do here at this point, we squared. So when you square 4, it's going to be 4 4 the okay, 4 4 the 16. Just a moment, sorry. All right. So can you now see that okay, so when you square 4, it is going to be 16, and by squaring both sides, the root will be eliminated. And you can see here, from here you can get the value of summation of x squared. So summation of x squared equals to, you have 16. If you transpose to the right, it's going to be 160 square, and then keep them into bracket, and it is divided. So when you transpose again to the right, it's going to be multiplied. And now calculate this. So it is 160 square, and then it is plus 16, and then you close the bracket, or you can put equal sign, and then times it is 20. So this value is going to be very big value, 5123220. So it is going to be 5123220. All right. And similarly, you have to work for summation of y square. And so you can also write, also we are given that sigma 2 value as, in that data the sigma 2 value was yes, the sigma 2 value is 3.5. so you can write here 3.5, and the formula for the standard deviation in this case will be summation of y squared by n2 minus its mean square equal to 3.5. If you like, you may square both sides and keep on putting the values. It is y square n2 is given as 30, and y bar is given as 155. So we write here 155 square equals to 3.5. And now let's get it ready to calculate. So summation y square is, so both sides you have to, when you square both sides, so you're squaring both sides, then you have to square here also. So it's going to be 3.5 squared plus 155 squared, and as this is multiplied here, so on other side it will go to divided here, so it will go to multiply here. And now again take the calculator. In the calculator we have 3.5 squared and then plus 155 squared equal sign, and then in the answer you have to multiply that with 30. So this is now 72117.5. okay, so we have now all the values available for combined sigma. So therefore standard deviation combined, and this formula is summation x squared plus summation of y squared over n1 plus n2, and then minus it is mean square. So if you put all these values, then it's going to be so just now we had seen that our summation of x squared is 5 1 2 3 2 0, and then another value is plus another value is summation of y squared is now 7 2 1 1 7.5, and this whole thing should be divided by all inside the root by n1 plus n2 means 20 plus 30 is going to be 50, and then minus what is the combined mean for this data. So combined mean for this data we had calculated as 157. Here you can also see 157. So we write here 157 square, because the formula you can see that there is a square. Now let's take the calculator. So it is, let's check that. This is 512320, and then this is 72117.5. all right. So you can work directly under the root, or you can take the root later, it doesn't matter. So it is 512320, 512320, 512320 plus 7211, 7211, and then 0.5, then 0.5. Okay, 72117.5 equal, then divide this by 50, again equal, then minus 157 square. So it is 157 square. So we have the values. So I think there is some mistake in the. So let's try the calculation again. So it's going to be 5 1 2 3 2 0, 1 2 3 4 6 digit, 1 2 3 4 5 digits. Why it is 5 digit only? So we have to check this calculation. So it is 3.5, and then 155, sorry, 155 square, and this is the answer, and this answer times 30 is going to be 721117. 72, oh, we have missed one over here. 72111. So there should be 3 times 1. So 1117.5. 72117.5, and then let's check the another calculation also. So let's put here 1. So it should be 1. So what about for? So it is 16 plus 160 square, 160 square, and then times it is 20, 512320, 512320. So this value is correct. So let's do it again. So it is 512320 plus 72117.5, and then whole thing divided by 50, and then it is minus 157 square. Yes, so it is going to be under the root 79 by 4, and then a square root of answer will give you, yes, so the answer is 4.4440, and few more decimals are there, so you can write 4.4 if you would like to express that to two significant figure, or if you would like to express your answer to three significant figure, then you can write again 4. So this is the value of combined standard deviation for those two sets of data. Let's see again. We have discussed about this formula, and also we have solved this problem. This is n1 20, n2 is 30. Then we use all the data in this formula, and our answer was 157. This is the combined mean. And so you can do this directly this way also, or otherwise by this formula, or by using this formula also. So in order to find by this formula, you have to first find summation of x. So x bar will give you the value of summation of x, and y bar will give you value of summation of y, and then use this formula, and then we have the same answer. Okay. And second part, it said that to find the standard deviation. So first of all, in order to find the standard deviation, you have to write the formula, and this is also given in the CIA formula booklet. First of all, copy this formula, and based on this formula, try to find the information that you required in this formula. So from x bar, we have summation x. From y bar, we have summation y. You don't have the value of summation x squared, so we know that standard deviation is for one data is this, and it's a standard deviation fortunately given here. So based on all the information, we can get the information for summation of x squared. And the similar work you can do for the another set of data. For girls, we say that data is denoted by y, so that is represented by y, and then we apply the same strategy, and then we get the value of y squared. Now we have information of x squared and y squared both from this formula. N1 and n2 are already given, and the combined mean we have already calculated. So put all the data in the given formula, and then we'll have the value of standard deviation. If in the same problem, if it says that like find the variance, you just square the standard active, square it at last. You don't write this sort of a square root sign. You just write instead of sigma to sigma square and square it, and then you can work directly also if it is asked you to find the value of variance. So sometimes it will tell you to find variance, and sometimes positive square. Okay, think on this for a while. But we are having problem in seeing all this clearly. May watch the record of the same. I'll leave it here as the record video, and then you can play it later on also if your internet is not good. Okay, now so we are done with this sum. Let's move forward to another, and this is also about the combining set of data again. Okay, now so it is. Let's do a start. It states that a test is taken by 30 students, and the standard deviation is 20. And then you have to find summation of x, and then to show that summation of x square is, so because the mean standard deviations are given, we can find these two information. So in question number 1, you are given that, what is it? Okay, is to summation of x, and then by n equals to 60, and then summation of x is actually n times of 60 or 60n you can write. Therefore your summation of x is going to be, is n given there? Yes, a test is taken for 30 students, so this is the value of n. So n is given as 30 times n is 30, so 30 times 60. So 6 3 are 18, and there are two zeros, 1 and 2, so 1800 is the answer. Now you need to find summation of x square, and you know this is the content of the standard deviation formula. So, and standard deviation is, and also your standard deviation sigma value I will write, or you can write SD is given as standard deviation is 20. Sometimes it will tell you that variance is given, so we have to take care of whether this is variance or standard deviation. So you know the standard deviation formula as summation of x squared by n minus x bar squared, or you can say summation of x by n whole square. So here, because we already have x bar and both we are now summation x also, therefore you can use either. So you should be able to express the formula for standard deviation in different form based on what you need according to the given problem ways. And this value is already now 20, and here both sides we square now. So when you square both sides, the root will be cancelled, so it is summation of x squared, and n value is, we have already now here 30 given, and then x bar square you can write 60 squared, and this is 20 square already here. So your x squared is going to be equal to 20 square. If you transpose to the right, it is minus, it will be positive sign here for 60 square, and this sort of thing is divided on the other side, is going to be multiplied. So let's take the calculator again, although we can calculate this mentally also, but better to use calculator. This is 20 square, then plus 60, then it is time 30. So this value is now have this value as 1 2, how many 0, 1 2 3 4 zeros, 1 2 3 4 zeros. So yes, 20 and 3 zeros, and then this is proved, because it says that so that this, and we have shown, therefore we can write proved. Otherwise we will write it is the answer. Okay, now it says that in question number 2, so you can say this as n1 as 30. Now in question number, no, in the same question, another 20 students take the test. That means another number of student is 20. So this is 30. Okay, another 20 students take the test. Their scores y are such that, so we are fortunate that summation y is y square is given as 100, that is 100,000 given it is. So fortunately we are given the total of y and total sum of square of ys. All right, now it says that so that the mean score of the combined 50 student is 64. Here again we have to show that, that means answer of the mean score is already given here. If you match the answer, our work is done. Let me take another paper for the mean score. So combined mean we have to find, so we are working with 2. So in this case is mean is combined mean, we know that this is summation of x plus summation of y by n1 plus n2, 1800. So we write here 1800, 1400, and then n1 is 30 and n2 is given, n1 is 30 and n2 is given as 20. So altogether there is 50 students, And then you can, although you can do this directly, better you take the calculator. So it is 1800 plus 1400, and divide all these by 30 plus 20 as 50. So it is now 64. So it is, we messed up with what we have to show here. So this is proved now. Okay, we have a third part also here. It said that calculate the standard deviation of the scores of the 50 pupils. It doesn't say that the combined standard deviation, but as it has talked about 30 students in one set and 20 students in other set, altogether they make 50, and so when it's combined. All right, you have to understand by the language of the question and also how it is given. So we have got this answer already. So combined standard deviation formula is now, you know that. So standard deviation is, better if you remember, so it is summation of x squared plus summation of y squared over n1 plus n2, and then minus mean squared. This is not the single mean, this is the combined mean squared. Okay. So yeah, just use this, that's summation of x squared. Now we have all the information available here. So okay, first of all I'll write under the root summation x squared value. Where is it? It's here. So it is 1 2 0. Then how many zeros? 1 2 3, 3 zeros again. 1 2 3. Then for summation y squared, it is, if you can see it clearly, okay, 100,000. So we write 100 and then 3 zeros. And n1 plus n2 means first it was 30, then in another set it is 20, altogether it is 50. And mean square means we are talking of this combined mean, so this is 64 square. And then the calculator again. So either we start with the square root, or first we calculate this directly, then root the answer. Then it is 120. How many zeros? 1 2 3. So 1 2 3 zeros plus 1 0 0 and then 3 zeros. 1 2 3. All right. Equal, divide this by 50. Okay. And then minus 64 square. So our answer inside the root is 304. Then root the answer. When you root the answer, it's going to be, if you want to have exact answer, it's going to be 4 root 19. 4 root 19. So this is the exact answer. If you'd like to have the answer nearest to the significant figure, you put SD over here. So in SD, it is now 17.43559, and few more decimals are there. But we'll express that up to 3 significant figure means up to here. We round off this number up to 3 significant figure means it is 17.4 up to 3 SF. So it is correct to the 3 significant figure answer. This is also possible that you write correct to the 2 significant figure, 4 significant figure, as it is mentioned in your question. Sometimes your question will tell you that to find the exact answer. In that case, you leave your answer like this. Okay. Otherwise, in general, you decide yourself. So this is a usual way to express the answer in 3 significant figure. I hope we are done with all. No. Yes. So it was question number 3. Okay. You can have a look at this question and think on that. हेर जो चाहिँ अब कपी पेन लिएर क्यालकुलेटर लिएर मजाले रेडी छौ मसँगै काम गरिरहेछौ भने that is going to work very well even though the net sometimes is not good. तर मुभी जस्तो कुनै प्रोग्राम जस्तो कुनै म्युजिक जस्तो मात्रै वाच गरेर बसेको छ भने मलाई लाग्दैन के फाइदा होला त्यही। तर एउटा कुरो प्लस पोइन्ट के छ तिमीहरूले यी कुराहरू हिजो अघि अस्ति कहिले क्लास थियो पढिसकेको छु त्यही भएर अलिकति बुझ्न सजिलो होला। But my suggestion is that you be ready with calculator, copy, pen, everything. Yeah, Adip Adhikari said hello sir, and Adit Subedi also said hi sir. So hi and hello from my side as well. Sometimes the internet condition goes unstable, but when you wait for a while, things will become clear soon. Okay, you might have done some calculations, and also you might have thought of the idea that how we do this kind of problem, and this sort of thing you might have seen, I assume, and then rest of the calculations are here. So you can have look over here also, and you can yourself calculate. Okay, then let's move forward. Let's see if there are a few more questions. Okay, now coding of data is remaining. So in the coding of data, usually if data value is, we do now calculation of mean and also variance or standard deviation by coding data. All right. So we require, for these days we have a lot of computer software calculators. So any sort of value we can calculate in few seconds or sometimes in fraction of second. But long time before, when this theory is on the way to develop, for example, we have x value as something like this, like 2 1 3 5 9 6 18, then 3 2 5 6, like this, 9 2 1 2 9 3 4 9 6 1, something like that. And if you look at this value, if there are only 4 values, for example, I wrote here, but if suppose that there are 50 or 60 values like this, then can you imagine if you are going to add them without calculator, how long it's going to take? Even if you square this number, for example, it will take a lot of time to find the square of only a single observation. It's okay. So coding of data method of finding mean and standard deviation were developed in order to make this sort of work easy over here. So in our A-level course, I don't think that we'll encounter such type of numbers here. So there are another way to understand the use of coding of data that we'll discuss here. So especially the coding were developed in order to make the calculation of very, very big numbers. But here, as the days passed, it has some different use also that we'll see in our A-level mathematics and statistics courses. Now, let's see what is coding of data. Coding means we choose any value roughly from given set of data, usually from middle of the data by our estimate. Middle means one person can choose 312516 at the middle by its weight or its value. Maybe another person can choose 34961. So both the persons will be correct in this case. But only the thing should be that we choose the value arbitrarily, which is supposed to be the central value as the representative of whole data. Okay, now let's talk about what is called deviation first of all. So deviation means, for example, if I'm taking x, means all these x, and how it deviates from value 31, for example 312516. So if I take the difference of each x from the my chosen central value as 312516, then this is called the deviation. And as we have used this number, therefore what we have done, we have coded or coding the data. Okay, so in general, let's suppose d as x minus a. So if you taking summation of sigma to both sides, what happens then? Actually we have d equals to x minus a, and we are applying 1 by n and 1 by summation 1 by n, some 1 by n of summation and 1 by n of summation over here. Then we are left with now summation of d by n equals to, now insert this summation inside the bracket, that means use the distributive law. It's going to be summation of x by n minus a is out, and then it is going to be summation of summation by n. Now what is summation actually? So summation means you can say nothing there, then times 1. And if you are using the prefix I, so I goes from 1 to n if you say, then times I means it is I to the power 0, because any number power 0 is 1, therefore I to the power 0 is also 1. So in place of 1 you can write I to the power 0. And when you expand it, it is going to be 1 to the power 0. So another time, the 1 to n means, 1 to n means what? 1, 2, 3, 4, 5, 6, 7, 8, up to n, up to the given highest value of the number. Then it is one time 1 to the power 0, another time 2 to the power 0, then 3 to the power 0, then it goes on and on up to value n to the power 0, and any number to the power 0 is 1, so 2 to the power 0 is also 1, this is also 1, and then so on, then this is 1. So how many 1 are there? So we work for n number of things, so altogether how many 1? There is n number of 1, so that whole thing is n. So you can cut them out, because this is n and this is also n, so these are cancelled out. And do you know what it is? This is summation x by n, means total number of observation by total sum of observation by total number of observation, and this is defined as x bar. So this sort of thing is x bar, and minus a times 1 is remained here. Therefore x bar can also be expressed as summation of d by n, and if you transpose to the left and taking right everything, then it is going to be a. That is, your x bar is going to be summation of d means what? X minus a we have chosen, so we can write x minus a and divided by a plus a. So what happens if you choose this formula? Then if you encounter the values like this, then if you say the difference between this value and your a value, I have taken this. So let me check. Okay, I can see that in Viber Sambandha is writing hello sir, but at this time I can reply to only the question if you make here, but I cannot see the message individually at this time. But you can write your confusion in the box provided. You can do so. And Sambandha, I think you are from A to S, and this time I am busy with A1 students. So we can meet next time, or otherwise, if you like to revise it, you can revise, no problem. Okay, so I was here. Yes, I was talking of this. I have taken a value as this, and x minus a means I'm taking 2, 1, 3, 5, 9, 1, 8, and then minus 3, 1, 3, 1, 2, 5, 1, 6. Suppose that this is 9 here. Okay, and this I have taken a, then another is 9. Then what happens? Yes, look at here. Like when I have taken this difference, the value has gone shortened here. Yes, small. So objective of coding is that to just try to sort the value so that our calculation will be easy. At this time you can do directly everything, but in the past time there was no facility of calculator and computer, so they used to have different sort of method developed in order to make their calculation easy. But here we'll use this further as well. So this is the formula for calculating mean by coding method. Now similarly you can, let's see. Okay, I know in some place the internet is not good, but here I can see mine is fine. So at this time you try your best to understand where to get the things clear over there. Otherwise I leave the record by the end of this session so that you can have a look later on also. But there is a lot of pause in between, so during the pause time you can start and then have a look at the main thing. And here, okay, so you now remember the arithmetic mean formula by this. Now I will discuss about the standard deviation formula by coding of data. So you already have here, you can see. So I am discussing about standard deviation by coding. So here you have now like d equal to x minus a. So what if I apply, because I have already discussed the thing, so I will write it directly now. Summation d by n equals to, is going to be summation by n and then x minus a. And if I like, I can write this as d bar, because these differences are also the number, so I'm taking the mean of those differences. There is a deviation, and if I insert this inside, so it is going to be summation of x by n minus a times summation by n only. And just earlier we had seen that this is in fact n, so n and n cancel out, and this sort of thing is x bar again. So how you can write here, d bar equals to x bar minus a, and note it down as equation 1 or 2 because we need it later. And now another thing is that, okay, now you know that standard deviation is equals to under the root 1 by n summation of x minus x bar whole square if I'm talking of individual series. At this time, when it is other frequency distribution, then we can just apply f, the same formula. And now I will try to express this sort of thing. So standard deviation x I have written here, and this sort of thing if I want to express in, so what I can do, I'll do some algebraic work in the same formula. So it is 1 by n, or whole thing by n, you can write in either way. So it is 1 by n I'm writing at this time, and then it is summation of what I will do inside now. I'll do here x minus d, and then minus x plus minus x bar minus d. What you can see that I have done this thing. I have taken minus d, and then I have taken plus d. X minus d minus common, so x bar minus d over here. Okay. Or what if I write d bar? If I write d bar, then I can do so also. So I am writing here x minus I have to explain something else. A plus b whole square formula. So this is a square plus 2ab plus b square. So I'll use the formula. I'll suppose whole thing as a and whole thing as b. So in that case, it is 1 by n summation of a square minus 2a, in place of b is x bar minus a, plus b square, means this is x bar minus a square, and then close the bracket. Okay. Yes, I have got another paper here. All right. And after this step, continue from that step. Now insert this 1 by n summation inside the bracket using the distributive law. So your standard deviation of x, you continue from here. So inside this, it is going to be 1 by n summation of x minus a square. So 1 by n summation I am taking inside this bracket to its terms. Then 2 is a constant, it will be taken out common. X bar is constant and also a is constant, so whole term is constant, so we take it outside of the summation. And then this is 1 by n, and we are left with summation x minus a. Now plus, here you can see both x bar and a are constant, so both of these will be taken out common. So a square, and then this is going to be 1 by n of summation only. Okay, in this way we have here. And now what we can do in the next step, here we are just doing the algebraic work. So this is 1 by n summation of x minus a square minus 2 x bar minus a. Will do nothing for that because these are constant, taken out common. Now here what we'll do, here it is, insert this again inside. So it is 1 by n summation of x minus a times a is constant, so it will be outside 1 by n summation only inside. Okay, so this sort of work for here is done. And now we have earlier seen that this is n and this is also n, summation is also n, so these are cancel out. So here in the last step we are left with x bar minus a square. Okay, x bar minus a square. And then another step, now we are left with summation of x minus a square by n. So 1 by n times a minus x minus a square can be written as x minus a square by n, and minus, let's see here, 2x bar minus a. What are we left with here? So this sort of thing is x bar, and n and the summation, they got cancelled out because summation is itself n. So we are left here with only a. So we are left with a here, and then at last we have inside the root x bar minus a square, and it is summation of x minus a squared by n minus, you can write, look at here, this is 2 times of x minus x bar minus a square and 1 time. So what is left with here? 2x bar minus a squared, because if you multiply this it will be a squared, and then is 1 time x bar minus a squared, so 2 minus 1 is 1, so negative 1. So it is x bar minus a whole square you are left with. And now you have d equals to x minus a, that you had already taken it before, and you have also found that d bar equals to x bar minus a. You can see here d you have x minus a, and d bar you have x bar minus a. So where you find x minus a, you can write d. Where you find x bar minus a, sorry, yes, x bar minus a, you can write d bar. So I'm going to write here, further to this step is, I write summation of d squared by n minus this sort of thing is d bar squared, but I have to express again in term of x. So what I will do, first of all, so summation of d squared by n minus, sorry, yes, you can write this, that means summation of d by n, because this is the mean of d. Since you can write d bar, so this is arithmetic mean in term of d, so that means summation of d by n. If that will be x, then that will be summation of x by n. And now you can replace back the value. So d value is x minus a. So you can write here now summation of, in place of d again, this is x minus a squared by n minus, here you can write this, this should be a squared, yes, x minus a and divided by n. So we are just replacing d by x minus a, and it was given as the square of 4. So therefore a standard deviation of x by coding the data is now become summation of x minus a squared by n minus summation of x minus a by n whole square. This formula looks a bit threatening, but it's not of that kind actually. So how you can develop this formula? Now we have to note that by coding the x bar value was, you can have look here, where is it? Yes. So your x bar formula has now become summation of x minus a by n plus s. It can also be called assumed mean. or you can say that arbitrary value, or arbitrary mean, you can also call it. And your standard deviation now become of x. Look at here how you can remember this formula. This is summation of x squared by n minus summation of x by n square. So originally we write a standard deviation by direct method formula is this, and it was that it was the proof that how we get to the formula for standard deviation in term of coding like this. So easy way to remember is, you can see here. So by direct method, it is summation x squared by n. So in place of x, there is everywhere you can see in place of x there is minus a and minus a. So you can only remember that how to write the standard deviation formula in the coding form. You just put minus a in x, and then you will have formula like this. So no need to learn this by heart. Once you understand this, understand the idea to know this formula, it can be easily written as like this whenever you need to. And I think I'm not that sure should be this sort of formula in the CIE formula booklet, but I'm not sure actually. But even though it's given there, it's easy to write. So what I'll do, it is summation. So in place of x, I'll write x minus a square and then n, then n. So we matched up with this term. Okay, and then it is minus of summation of x. Then we have to take minus a over here, then close the bracket, divided by n and whole square. So we have this term. Isn't that easy to remember this formula? Okay. So now we'll use these two formula in order to solve the further problems which are given in terms of by coding method. So just set this formula in your mind so that your work will be easy when you go to solve the problem. So this note, I'm looking for the, where is it? Number 1F. By using the concept of that coding of data, it is known that for 100 observations of x, the mean was x bar equals to 25. Find summation of x. Think that whether or not you are able to find now. Then you have to find this also and this also. And after that, it says that given also that the standard deviation of x is 3, find summation of x square, and this information. So have a look at this question number 18. I'll be right back. I hope some of you have been trying this question number 18. Okay, let's do question number 18 now. This question number this is question number 18. It says that it is known that for 100 observations, so in question number 18, number of observation is 100 of x. The mean is given as, that is x bar is given as 25. In question number 1, you have to find summation of x equal to what? So we have x bar equals to summation of x by n, or summation of x equals to n times of x bar, and n value is 100. X bar value is given as 25, so you see it is 2500, that is 2500. And what about this? In question number 2, summation of x minus 20 equal to what? So here what we can use, so here you can use the formula of x bar in terms of coding of data. So it is x bar equals to summation of x minus a, means x minus 20 you can write, it can be any value, divided by n is 100 you can see, and plus a again, so it is 20. So what we have used, that x bar formula in the coding form is summation of x minus a by n plus a, and in place of a there is 20, so I wrote 20 over here, and I require now this value. So in this case, now x bar we have it is 25, and then it is, because we require this, so x minus 20 over 100 plus 20, solve it, then it is summation of x minus 20 equals to, it is 25. If you transpose this to the left, it is going to be minus 20, and times, it is 100 is divided, so in the other side it will go to multiply, so this is 100, and then this is 5 times of 100 is 500, so 500 is the answer. And similarly you can try for x minus 27 here, so just replace 20 by 27, then you will have value of summation of x minus 27. Okay, now in the other part, the question says that given also that a standard deviation of x is 3. So in the second part, it is given that a standard deviation is 3. Then in question number 4, summation of x square equal to what? So you know that a standard deviation is 3 given. So a standard deviation is summation of x square by n minus x bar square, you can write. So x bar is somewhere here. 25 is also given here, so it is 25. So you can write here 25 squared equals to 3. Now squaring both sides, then you have summation of x squared by n. N is 100. So you can write 100 minus 25 square is 625, and this is 3 3s are 9. So what we did here, we squared both sides. So we square to the both sides, then it is summation of x squared is going to be equals to 9 plus 625, and then it is divided, so on the other side is going to be multiplied. So it is, how much it is then? 634 times 100, and finally it is 63400. So this is the answer. Okay, and similarly let's try for this. Now I'm with question number 5 now. By coding, we know that a standard deviation, so standard is already given is 3 here first of all. So by coding method, standard deviation is summation of x squared, then we write x minus a. In place of a there is 20, so 20 square by n is 100 minus summation of x squared means x minus 20 and divided by n, that is 100 square, and this is the position of mean equal to 3. You can square both sides also. It is summation of x minus 20 squared by 100 minus, inside the bracket, summation of x minus 20 was, let's check, yes, it was 500, or you can use the mean value directly also, it is also possible. So this value is x minus 20, x minus, yes, so we are here, yes, x minus 20 is, you can see it is 500. So we write here 500 and divided by 100 square, and square by squaring both sides, this is 3 square, and these two are cancelled, so it is 5 5 ja 25, and you can see that the mean was given as 25. So it is now summation of x minus 20 square is equals to 3 3 are 9 and 5 5 are 25. So it is yes 5 5 are 25. So it is 9 minus 25, so plus 25 now, and then this is whole thing time is going to be 100. So it is now summation of x minus 20 whole square is going to be, it is 3400. So this is the answer for that. And our summation of x square was yes. So summation of x minus 20 square is found to be 3400, and this is the answer. Let me see if there are a few more sums that we can do. Lastly, let's do one more from this book. You can see in question number 7, a machine cuts lengths of wood. A sample of 20 rods gave the following results. Following results for the length x equal to this. Find the mean length of 20 rods. Find the variance length of the. I think we have done this before. So that is all for now. All of you, take care. We shall meet next week in the class. So thank you for watching, and this is all for now.